You will be able to identify the three main subatomic particles and the experiments that led to their discovery. There are three important subatomic particles that I'm going to discuss: protons, neutrons, and electrons. You see, it was once thought that atoms were indivisible, that they couldn't be divided into anything smaller. However, they can be divided into these smaller subatomic particles. The protons have a positive charge, electrons have a negative charge, and the neutrons have no charge. They're neutral. And the nucleus lies at the center of every atom, and it is composed of protons and neutrons. The nucleus is extremely dense. It contains most of the mass of the atom. If an atom weighed 1,000 pounds, the nucleus will weigh 999.99 pounds. That's how dense the nucleus is. Almost all the weight of an atom is inside of its nucleus. However, the nucleus is extremely tiny compared to the whole atom. For example, if the atom were the size of a football stadium, the nucleus would be the size of a football. So this football would be the nucleus of the atom if the atom were the size of a stadium. And if this football were the nucleus of an atom, all of the weight of every person in the stadium would be contained within it. Now, the nucleus was discovered by Ernest Rutherford, who conducted the famous gold foil experiment, as the video will go into detail about.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.
Now onto the electron. The electron determines the chemical properties of an atom. So electrons are extremely important. They're negatively charged, and they were discovered by J.J. Thomson, the scientist who conducted the cathode ray experiment. Now, the way the cathode ray experiment worked was that he had what's called a cathode ray tube, which is in this image below. And one end was called the cathode, which was negative. The other end was called the anode, which was positive. And he filled it with a gas and ran an electric current through it. Now, when he ran the current through it, he noticed that particles traveled from the cathode towards the anode. So these particles were repelled by the negative cathode, and they were attracted to the positive anode. And he determined that since these particles were attracted to the positive side, then they had to be negative, because negative and positive attract each other. So he named these negative particles electrons.